In this lesson, we'll be reviewing how to go between atoms and grams. You have to remember that 1 mole is equal to 6.0 times 10 to the 23rd atoms, and that molar mass is in grams per mole. We could either write 1 mole over x grams, depending what the element is, or we could write grams over 1 mole. So another thing you have to remember when doing these problems, going from atoms to grams or grams to moles, is that you always have to get to moles first. You have to get to moles first. Okay, so let's give it a try. We're going to start with this first one, and it says how many atoms are in 2.54 grams of aluminum. So we start with what we're given. Make sure we put the unit in and the substance. And we're going to follow my rule, and we're going to get to moles first. Okay, so we know a relationship between grams and moles. For every 1 mole of aluminum, there are 26.98 grams of aluminum. Remember that this 26.98 comes from the periodic table. The atomic mass under each element tells us also its molar mass. I'm using the molar mass as a conversion factor. Molar mass is 26.98. The mass you'd be doing would be essentially dividing by its molar mass. Okay, so we're going to cancel out our grams, and right now our unit is moles. Instead of stopping there, we're going to go all the way to atoms. The problem asks, how many atoms are in this amount of grams of aluminum? We're going to keep continuing. So, we know there's a relationship between moles and atoms. We'll put moles on the bottom so our units cancel. And we know for 1 mole on the bottom, we're going to put 6.02 times 10 to the 23rd atoms of aluminum. Okay, let's cancel out our moles, and we'll be left with the unit of atoms of aluminum. To do the math, you do everything in the top, divided by everything in the bottom. You can ignore the 1s because anything multiplied or divided by 1 is itself. So in your calculator, you're going to do 2.45 times 6.02. Hit that exponent button, that E, capital E button, E23. All divided by 26.98. And when you do this in your calculator, and round to significant figures, you're going to get 5.47 times 10 to the 22nd atoms of aluminum. Okay? That's going from grams to atoms. Let's go the other way and do atoms to grams. We've got 3.5 times 10 to the 23rd atoms of silicon in this problem. And it wants to know how many grams there are. How many grams are in 3.5 times 10 to the 23rd atoms of silicon? So let's get to moles first. The intermediate step is always to moles. We know a relationship between atoms and moles. There are 6.02 times 10 to the 23rd atoms, which I'll put on the bottom so my units cancel for every 1 mole that I'll put on the top. Okay, so our atoms cancel. Then our next step would be to get to grams. And we know a relationship between moles of silicon and grams of silicon. We look at the periodic table and we see that the molar mass of silicon is 28.09 grams of silicon. So we cancel out our moles. And in our calculator, we're going to put in 3.5 E23 times 28.09. Not going to care about the 1s again, so anything multiplied by 1 or divided by 1 is itself. Then we're going to divide by everything in the bottom, 6.02 E23. And the answer that we'd get rounded to two significant figures, 16 grams of silicon. I hope that helped you read going between atoms and grams.